talk about polar NRZ. I remember from a few classes ago, polar NRZ, all that means is at 0 is equal to +1, NB samples of +1, and S1 is NB samples of -1. And let's pick H of K equals, generally we will show in a few classes that the optimal form of the filter is H of K is equal to S0 of NB minus K. So let's pick that. H of K is S0 of NB minus K, which looks like this. At K equals 0, this is S0 of NB, which is 1. At K equals 1, this is S0 of NB minus 1, which is 1. And so on. It's +1 up to S0. If K is NB minus 1, what do we get? We get NB minus NB plus 1, S0 of 1, which is this. If K is equal to NB, then we have S0 of NB minus NB, which is S0 of 0, which is what? 0. So in other words, this is, H of K is equal to S0, basically shifted 1 to the left. So S0 of K plus 1. We showed this last time, let's not go through it, but S0, which is the convolution of S0 of K, equals with H of K evaluated at time NB is equal to NB. And S1, because S1 is equal to minus S0, what do you think S1 is? Minus NB. Convolution, it should be pointed out, is a linear operator. So if I, for example, multiply S0 by a scalar like -1, that scalar comes out. That scalar will still appear here. What else did I say last time? I said Z, threshold is 0. Again, it turns out that that is optimal if the two bits are equally probable, which they usually are. But we will prove that later, possibly later today. So let's plug this into the equation. So we have probability of error. Probability of error given 1. Oh, by the way, we also need variance sigma squared, which is equal to N0 over 2TS times the sum from I equals 1 to NB. Actually, it's the sum over all samples of H of K. In this case, the sum from I equals 0 to NB minus 1, H of K squared. And that is equal to N0 over 2TS, sum NB minus I equals 0 to NB minus 1. What is H of K? H of K is just S0 shifted to the left by 1, so all of these samples are equal to what? 1. 1 squared is still 1. So what's the sum from I equals 0 to NB minus 1 of 1? So basically there's NB copies of 1, so that's equal to NB. So we get N0 over 2TS, that's NB. All right, probability of error is equal to probability of error given 1 times probability of 1 plus probability of error given 0 times probability of 0. This is equal to, this I said is 1/2 curve C, Z minus S0, excuse me, S0 minus Z, divided by root 2 sigma squared, times probability of 1, plus 1/2 curve C of Z minus S1 over root 2 sigma squared, probability of 0. So let's start substituting in here. I'm going to keep that and just erase the top of this. So now going back up here, we have 1/2 curve C of S0 is NB, and Z is 0, so that's NB divided by root 2 times N0 over 2TS NB. So that 2 cancels with that 2, and that TS goes to the top. I have NB in the numerator and square root of NB in the denominator, so I can reduce that down to root NBTS divided by N0. Times the probability of 0 plus 1/2 curve C of, what do I have here? 0 minus S1. What's S1? It's minus NB, so that's 0 minus negative NB, which is what? 0 minus negative NB is NB, divided by root 2 sigma squared. Sigma squared is N0 2TS NB. In fact, we have exactly the same expression there as there. So I can exchange that for root NBTS over N0, probability of 1. At this point, so this is the same as that. So I can take out probability of 0 plus probability of 1. What's probability of 0 plus probability of 1? 1. It's just 1 because it doesn't actually matter what the two values are, because there's only two possibilities. Those two probabilities must be summed of 1. Which is equal to 1/2 curve C root NBTS over N0. Okay, let's get some numbers here. Let's say NB is equal to 8. Let's say TS is equal to 1.25 times 10 to the minus 5. And let's say N0